morning, everyone. I'm Andrew Waugh from Waugh Thistleton Architects. I'm going to talk to you on this rainy London morning about the work that we've been doing in timber for about the last, oh my goodness, nearly 20 years. Anyway, this is us. That's me in the middle at the bottom there in the red shirt. I'm the oldest. And we're an architect's practice in East London. And we built our first cross-laminated timber we sold. Not only was this building with a low carbon building material, a building material that's actually magically made of carbon itself, but also the prefabricated nature of the material meant that what we had drawn in our studio was exactly what had arrived on site. And those guys kind of putting it together with these cordless screwdrivers, that level of precision, that level of care and attention to the detail of the project was something that we were really sold on. And then the end result as well was a gorgeous little building. So we've been sold ever since. But a lot of the discussion over the last decades around sustainability, around low carbon, has been driven by operational energy, has been driven by the amount of energy that it takes to heat, light, cool, power our buildings. Now, this is a building here by Sir Norman Foster, Lord Norman Foster, and this building won all sorts of plaudits for its amazing sustainability. And yet, every single thing on this building is completely bespoke. There are loads of different types of stone from all over, shipped in to kind of like be hung on this concrete frame. They spent £100 million over and above building code for their operation, to reduce their operational carbon. And yet actually, the guy who designed that told me that if they put a poster up outside the front door of this building, and in the summer the poster said, take your jacket off, and in the winter the poster said, put a sweater on, they could have saved all that money. Now, what I'm trying to say by showing this, by illustrating that, is that actually, these kind of small incremental benefits to operational energy that we've been focused on for years have allowed us to build the same architecture in the same way, but just put a solar panel on the top. The conversation hasn't changed. The way that we design, the way that we think about buildings hasn't changed. And yet what we all know, I believe at heart, is that actually what is called for is transformational change. What is called for is a total re-examination of the way we think about our buildings and the way that we measure success in architecture. So what I want to talk to you about today is an exploration, really, that we've been going through as a practice, not only in building in timber and researching about timber, but also thinking about the way in which we design our buildings, the way in which we celebrate specialness about architecture. And we know that building with concrete and steel is incredibly polluting. I mean, the cement, this is in the BBC, so we know it's got to be true, right? The production of cement globally is more than has emissions more than 3 times that of airline travel. And yet this is not a talked about problem. We know, for instance, in Sweden recently, they've just closed their lime quarries for the production of cement because of the impact that they're having on the environment in Sweden. We know that actually the business of selling sand for concrete is now largely controlled by mafia because there's such a world shortage of sand. So these materials, these extractive materials, these materials that we scrape off the surface of our planet and that we can never replace and that are very hard to recycle, especially cement and concrete, obviously. These materials we need to rethink our kind of 20th century love affair with these materials and focus on timber. So in 2007, we got a lovely commissions project, very simple site in East London, 17.5 meters by 17.5 meters. The local authority had zoned it for 9 stories only. We knew exactly what we could do. And we spent some time looking at an opportunity here to build this building in timber. And we were able to demonstrate to our clients that actually building in timber would be so much faster. We could take about a third of the building program, that it would in fact make the whole project much more cost effective to build in timber. And so in 2008, we completed really, I think, the world's first tall building in cross-laminated timber. 9 stories, 29 apartments. The entire structure went up. 4 people built the building in 27 days. And it was really simple. We kept it really simple. So every apartment stacked above the ones below in the same kind of like for the same sort of 3-bedroom after 3-bedroom after 3-bedroom, if you see. So very simple kind of internal layout. You can see here just galvanized shelf brackets, 75 millimeter with 120 millimeter screws. Very simple kind of ceiling tags here, plastic ceiling tags to bring the services through, and really quite rudimentary in terms of the CLT. You know, in hindsight, we used, well, actually, we've had a look at it since, we probably used about 40% more CLT in this job than was necessary for the structure. So an incredibly strong building. But, you know, through the process of that construction, we found out some really fascinating further advantages, such as, you know, through prefabrication, there's no waste, there's no side waste. You know, we had like one skip, we just kind of sits there for weeks on end, and very, very quiet, because the whole thing goes together with cordless power tools. Then you've got no jackhammers, no grinders, so really quiet. And, you know, this building here is within about 9 meters of some adjacent residential windows, and yet for the whole period of construction, not a single complaint, and far fewer deliveries as well. So the prefabrication, the fact that it's very, very light, weighs 1/5 of concrete, of a concrete structure. So a lot less material coming to site, a lot less impact in terms of road and traffic deliveries, which is a big deal in London, especially in kind of like, you know, in the central areas where the constant kind of like trundle of construction traffic is really kind of quite polluting and very disturbing. And so in 2009, we had a kind of an unprecedented amount of interest in the project. We were kind of sort of taken by surprise by that interest, and lots of people contacting us and asking us about details and stuff like that. And so we sort of sat down as a practice and had a careful think about how we were going to proceed with this. And we made the conscious decision that we were going to be completely open about everything that we did. And it would be completely open source, that we would share drawings, that we would share travails, you know, that we would share successes as well as failures. And so in 2009, we wrote this book along with the engineer and with the material manufacturer, Karl-Heinz Weiss and Matthew Wells. When we wrote this book, A Process Revealed, and this really is an explanation of the whole process of designing and building this building. And that's really been a kind of sort of a core plank of our ethos as a practice since those days, since 2009. And in 2012, a couple of years later, I was lucky enough to buy a piece of land with 2 of my best friends. And so that's my apartment here in the middle. So, and my friend Dan and Nick, they live here, and Jason and Laurie live here. And then we sold the 3 floors down here, and the middle floor we sold to a photographer, and that photographer needed a completely open space. So what we did was to use the party walls between each one of, I hope you can see my mouse, use the party walls between each one of the apartments as a deep beam. So those deep beams hold up the floor slabs to either side. And so the apartments are suspended over this big open studio below. And those apartments suspended, if you like, in midair, allows us to have a column-free, beam-free open space down here to work as a photographic studio. So what I think is particularly interesting about this building is that we then began to explore not only a different construction process as we've kind of experienced on Murray Grove, but to begin to understand that actually when you change a building material, when you make that fundamental change, just like happened 100 years ago with concrete and modernism, But when you make a fundamental change with the building material, actually the opportunities for a different type of architecture arise. And so really that's been the core focus of our work for the last 10 years or so. And that's it there without, before it was clad. So it's my apartment there where I still live, nearly 10 years later. And that's us in one Australian summer. And we've gone on to build about 26, 27 projects across the UK and in France. This project here, the largest completed project so far, so 17,000 square meters and 37 meters tall, 121 apartments and 4,000 square meters of commercial use. Now that building in concrete would have weighed over 10,000 tons and it would have required hundreds on hundreds of cement trucks coming to site every day, pounding through the streets. And yet in timber was less than 2,000 tons and less than 100 deliveries of timber. So, and it was very fast as well. One team put up this building in just under 5 months, 17,000 square meters. And you can see just quite how fast it was, because by the time the train has gone past, the building is finished. And so we sort of were reflecting, after that project, reflecting on the number of projects not only that we had done as an office, but also that have been done across the UK. And in conversation with the US Department of Agriculture, with the Forestry Service, we produced this research piece in 2018, which was where we interviewed and spoke to the design teams of over 200 engineered timber buildings across the UK. So we spoke to the clients about how their experience process, to the contractor, and to the design teams, not only for their successes, but also, you know, where the challenges been in those projects. And this book, this study, is still available online on thinkwood.com. And so what we were able to ascertain from this is really kind of a progress of a new type of architecture through the UK over the last 15 years. And more recently, we've completed projects where we began to look at greater detail in the opportunities of prefabrication and also different types of engineered timber. So this project for Vitsu, which was completed a couple of years ago, was designed in conjunction with Vitsu, was a really demanding project in many ways. Demanding because Vitsu came to us and said that we want a building as accurate and as precise, as flexible and as interchangeable, as demountable as our furniture system, as our shelving system. So this beautiful shelving system, designed by Dieter Rams in 1960, is this fantastic flexible system where you have these vertical rails and then you can get different sizes of shelves that kind of key into the vertical rails, and you can also get drawers, hangers, and all sorts of things. You can take it from place to place. In fact, I myself have got some of this shelving, as you might imagine, and I've had it for like 35 years. It's my first piece. And being able to build on that and extend on that. So that idea that you could take that kind of precision and simplicity and adaptability into an architecture, I think is incredibly exciting and important as well, because the buildings that we need to be producing now need to be buildings that last well into our future, that we can reuse, that we can adapt, that we can, you know, that we can change with kind of like, you know, with shifting demands. And so this building has become an important part of that conversation for us as a practice. And you can see, so here we are, this is the external skin, is a softwood CLT, and these north-facing, of course in Australia, south-facing would be south-facing, skylights to give natural daylight through the building. And so you can see inside the factory here, now we're using an LVL frame, so that's like a plywood. Rather than planks, you use a CLT or for glulam. This is veneers, construction veneers, so 3 or 4 mil thick, laid out 4 times parallel, then the fifth layer perpendicular. So you're still getting that kind of cross-grain strength. But this is with a hardwood, with beech trees. And this material is incredibly strong. So a GL70, about as strong as steel in section. So you can see this beam across the site here. This is about 25 meters across and no more than about 500 mil deep. And these columns, you can see how slim those columns are supporting that beam along its run. And if you see the grooves in the columns there, those grooves allow a Sherpa connection to fit into those grooves. And these beams here, which were left for the occupier to use, these beams here can form mezzanines, which can be built lower, higher, replaced, and moved around through the factory. And so this is the factory complete, and you can see the amount of natural daylight coming in through these skylights here is enough during the day to light the whole entirety of the plant inside. This is a stabilized earth slab, so no piled foundations, merely kind of a raft foundation, sort of a trench foundation under each one of the columns, and a very simple system where you can see here this beam was put in afterwards to build this kitchen unit here. So we've got a little kind of canteen at the end, a little library here. There's even a ballet school now alongside the manufacturing plant. So, and also the scheme was adapted. So about 2/3 of the way through the project, the building was doubled in length as well. And so we've taken that kind of idea, or those sort of principles of technology, to a current scheme that we have in central London, which is an office building, about 5,000 square meters, just under 5,000 square meters of co-working space. So quite an intense use for office space in central London. And again, we've taken some of the lessons learned from Bitsu, so using the LVL frame, using clear glazing across the building. And that clear glazing allows us to really experience the day outside. So some of the health and well-being benefits that we know that we get from a timber building, and I think you can see them in here. You know, you can understand the experience of working in this building and the kind of the joy of being surrounded by timber. And I know that Planet Arc in Australia have done some great work as well. Stora Enso, again, done some great work on the health and well-being benefits of being in a timber building. But I think that clear glazing, being able to understand the kind of the nature of the day outside, is also an important aspect of that. And so this building here has that clear glazing, and what we've done on the outside is using a parametric modeling, we've put across a solar shading across the building, and the number of shades and the depth of those shades, so how far space they are apart is formed by this parametric model. So the building itself has this massive basement in it, unfortunately a demand of the local authority for cycling and waste, etc., like that, for cycle stores, etc. And it's about 40% of our carbon budget of the whole building is just made up of the basement. And then we have a CLT core here in the middle and CLT floor slabs, and then the LVL frame here. And that LVL frame, we're able to, because it's so strong, we're able to actually emulate the kind of grids that you would get on a steel frame building. So this is a grid system based on a 1.5 meter standard grid, which is kind of absolutely requirement for the UK commercial market. And so we have a building here based on a grid system of 7.5 meters and 9 meters. And these LVLs able to support that. In fact, the LVL supports the gravitational load, and the CLT takes the shear forces. So the CLT floor slabs are screwed into place with the beams so that they're able to provide a diaphragm action strength across the plan. So they're tying this grid of LVL columns and beams, they're tying that grid together, and then the CLT lift shaft and core giving us that stability, that stability against wind. So really strong, tight little building. You can see that's it just a couple of days ago. So you can see the LVL frame there going up with the CLT floor slabs and the core at the back. And again, you can see that those connections that we have, how the columns are connected to the beams, they're done in, those connections are in steel, but buried within the timber. So the timber provides the fire protection for the steel. And the carbon in that structure, we would have had over, just in the structure, over 450 kilos of emissions per square meter in a concrete building, 265 in the timber, of which, don't forget, about 40% of that is just the basement. But if we count the sequestered carbon, so that's the carbon that will be absorbed by the trees that have been planted to take the place of the trees that were cut down. So essentially, it's not about the carbon in the building, it's about the carbon that will be soaked up by the trees that are grown. So an essential part of the husbandry, if you like, of a building like this is to ensure that the trees that we use are certified, so that certification process ensures that those trees are replaced when they're felled. So those trees that replace the ones that are felled, the amount of carbon dioxide that they're soaking up, if we count that within the building, we're actually only 55 kilos of carbon dioxide, so nearly a tenth of what it would be as a concrete equivalent. So really important level of savings. And you can see the kind of, where we are in terms of the piles, the reinforced concrete walls, the slabs, etc. So the carbon in the structure representing a massive amount there compared to the CLT walls and floors and the columns above. And this is if you take the basement out, the kind of savings that you're going to get immediately. So about 690 square meters of basement. So we're having quite a campaign against basements at the moment, as you can see. This building, again, same sort of principles as Murray Grove in 2007, is really keeping it simple. So no kind of acrobatics. This is about celebrating an architecture of space and light and material, simple junctions, beautiful kind of clean spaces. So you can see here these connections buried within the timber structure of the LVL. And here we have this angle across the beam, tying these floor plates into the structure, providing that kind of diaphragm action. So it's always for us about how we can use as little timber as possible, how we can be as efficient with the material resource that we have. So that will be it finished and full of hipsters, just like our Shoreditch. So we've gone not only to commercial projects, but residential projects as well. This is our biggest project at the moment. It's sort of stalled with the city, but this is a plan for Bergen in Norway, and this is a sort of a floating new part of the city. So I wanted to talk to you about this because this has an aspect of a kind of regenerative use to it. So it's thinking about an architecture that doesn't just reduce its impact, but an architecture which always looks to improve the situation. So we have here in Bergen a quite kind of polluted lake between the old city on the left and the new city on the right. There's a public transport system being erected at the moment, and that public transport system is throwing up loads and loads of rubble. So the idea is to use that rubble as the foundations for these buildings. And then from the scale of the development, to be able to kickstart a CLT industry within Bergen itself. So therefore providing jobs and providing kind of opportunities for green, low carbon construction in the future. And then in addition to that, on the low-rise buildings here, where the foundations are made up of a gabion wall foundation, using the rubble from the new transport system, we've actually designed a kind of an oyster bed, so a massive kind of city for oysters. Now, oysters can clean up to 20 litres of water per oyster per day, and so actually the level of pollution within the lake will be able to be cleaned and filtered by these oysters in the beds, in the foundations of the building. Now, buildings like this, how you work with kind of different heights and foundations. So as you see in the previous image, starting with sort of 3, 4, 5-story buildings at one end, and then building up to the northeast with taller 14, 15-story buildings in timber. And public spaces along the lake's edge here with a marina and a natural swimming pool, and then ensuring that these little buildings with this kind of like, you know, with this sort of with the water coming through them, this kind of porosity within the development, and then each one of these developments kind of forming each one of these sort of keys forming its own little community within those spaces. And you can see a development which is planned, you know, for the whole community, for young and for old. And this is the footbridge, cycle footbridge, which will link the new part of the city here on the horizon with the old part of Berlin in the foreground, and then the view across the lake. And we've continued to work sort of outside the UK, so some affordable housing in Paris that's just actually been completed. Work in Stockholm, on the outskirts of Stockholm. We have new buildings in central London, offices in central London, large office building in Amsterdam, another one in Milan. And in fact, within the office now, we have over 100,000 square meters of office buildings alone, and about 5,000 residential units, all in timber. So this is an opportunity, you know, this is a real, you know, timber revolution that's happening here. So these are LVL and CLT structures and glulam, using as much exposed timber for that health and well-being, reducing the amount of materials, constantly being resource efficient, resource conscious in the buildings that we build, and looking where we can as well at improvements in the way in which we build. So one of the things that's really kind of, you know, that we began to understand through our work is this. It's how buildings are built now. You know, 100 years we've been building buildings so badly. You know, since England won the World Cup, it was an important date, obviously. Since England won the World Cup, we've actually reduced the productivity in construction by nearly 20%, while other manufacturing industries have increased productivity by 230%. So we're building buildings more slowly, more expensively than we were 55 years ago. And this is obviously crazy. So we're looking today at how we work with modular housing, how we bring more of that construction process into the factory, so that more of the solutions are less bespoke. So you're not treating each new building as a new project, but actually treating those buildings as products, sort of enshrining quality into those. I mean, if you think about a car, when you buy a new car, the sort of choices that you have with the internal finishes, the level of, you know, the warranties that you're able to get, and you think about a new building, how many times do people have to go back to repair things? You know, what the kind of, the lack of choice that's provided, you know, as long as it's a kind of white box with a sort of, you know, sufficiently mundane kitchen and bathroom in it, you know, then that's the kind of zenith of sort of residential development. Whereas actually what we need to be producing is higher quality homes. So this is one we've got going up in East London at the moment. This is a social housing building made of modular CLT boxes. We're also looking at other ways of doing that. So this is kind of pod and panel solution where we're prefabricating bathrooms and kitchens and then flat packing the walls and the floor slabs and then building those up. This is a building we finished a few years ago in Brighton, in the south of England, which is a student housing development using prefabricated facades, prefabricated bathroom units, and then flat packing, so I was saying flat packing the walls with all the electrics in them, all the services embedded within the walls, bringing those to site and putting them into place. And this building finished in about 10 months entirely. Now we can do that because of the kind of level of BIM modeling that we're able to produce. So the sophisticated CAD models that we're able to produce in our studio now allow for that kind of accuracy, for the sort of for the accuracy of that prefabrication. Now that's something that we've got interested in as a practice, realized that actually one of the major issues stopping the development of this kind of work is actually being other architects not thinking it's exciting. So we wrote this book, again, this is available online, New Build Modular Housing Guide. And this is about talking about how exciting building modular housing is, what great opportunities there are to actually ultimately provide people with better homes. And we've had some fun too. So this is something we did a couple of years ago, which for the Victorian Albert Museum, working with the American Hardwood Council. And the American Hardwood Council kindly shipped us over a couple of tons of their worst timber, their worst hardwood timber. So this is tulip wood. This is a sort of scrub tree that grows in the States and across the States. And it's generally used for cardboard, for making pallets out of that kind of thing. And we took that material and spoke to the Victorian Albert Museum in central London about doing an installation based on kind of ideas around modular housing to try and sort of make this a more attractive kind of like idea to talk about the opportunities that are available, and also to talk about how strong engineered timber is and what we could do with it. So each one of these boxes is engineered to take 35 people inside each one of the boxes. And these boxes are only 75 mil. The CLT is 75 mil thick because it's hardwood CLT, incredibly strong. So you should be able to see this little film here of it going in. It's about 4 days of installation. So you can see really tight little space. The boxes coming in here, little spider crane putting those up. And we had, and this was up in the Victorian Albert Museum for a couple of weeks. And after the Victorian Albert Museum, we've taken it to the Milan Design Festival, to the Madrid Design Festival, and it's now back in the UK at the Design Museum in central London. And will also be featured at COP26 in Glasgow. So this is it. We had an amazing amount of people come through. We had about 1.5 million Instagram posts, excitedly. So really kind of getting that story across. And I just wanted to kind of touch on some of the other work we do. I mean, as a practice now, about a fifth of our work is purely research work, looking at opportunities for timber construction, for detailing, for efficiencies in construction, for design solutions, for various details, and what the kind of new architecture from timber might be about. What are going to be the real drivers there? So this is a 4-year project that we're doing for the European Union, looking at different structural systems, how those are affected by different building codes across the European Union, working out a parametric modelling system for both residential and commercial buildings, looking at costs and efficiencies in timber construction systems. And this is some kind of, from the same brief, this is kind of parametric, this is the kind of systems, the buildings, the forms of buildings that can be thrown up within the same parametric system. And this is our first building, looking at that, looking at designing with that sort of system. This is in Milan for Lend-Lease, 44,000 square meters, 2 buildings on the mine development. But again, with that kind of parametric systems, with those sort of timber construction systems, celebrating still the kind of, the nature, the well-being, the health benefits of being in a timber building. And also, the kind of the simplicity, the kind of the space and the light, and celebrating the material of those open spaces. And in the UK, another piece of research that we're doing, where we've had, unfortunately, changes in building code in the UK that have limited, uniquely in the world, limited our opportunities of building in timber. Working with the local fire brigade, working with insurance agents, to actually see what we can build within code and how we can do that in order to provide residential construction system for 6-story buildings in timber, residential buildings in timber, and how we can do those with a kind of pre-warranted open source system. Very simple, straightforward details that then other architects, contractors can use those details and model their own buildings depending on the brief and the context of those buildings. So it's designing up a system of construction we call the new model building. And also at the moment, I'm really fascinated by what the opportunities in the future might be of a new timber architecture. Now, this is a picture of Manhattan. These buildings in Manhattan, these tall buildings, the average age of these buildings, about 70 years old. Now, the concern in Manhattan is that, you know, these buildings are fast becoming redundant in terms of, you know, in terms of their use, in terms of kind of the demands from the occupiers for higher grades of space. And yet, to demolish these buildings is not only incredibly carbon intensive or carbon wasteful because of the embodied carbon already stored in those buildings, but you can imagine that demolishing one of these buildings, taking out all that concrete steel through the Holland Tunnel, and bringing all the concrete steel back through the Holland Tunnel to rebuild these buildings is incredibly labor intensive, incredibly kind of drawn out process. Could take, you know, several years to in fact demolish one of those buildings and rebuild one. So we've been looking at what the opportunities might be for adding additional structure, because a lot of these buildings, the vast majority of these buildings, are massively overstructured, and so have a lot of redundant strength within the concrete and steel structures within the existing foundation. So because structural timber is so super lightweight relative to concrete steel, we can in many cases build additional floors. We can extend additional floor plates without having to redig or strengthen the existing foundations. So with these projects here, we can also build in adaptability into those floor plates by having sections of floor which are removable, which can be taken out, put in the elevators, stored in the basement, etc. So this is a modeling of one of those and the opportunities that that can provide. So I think some really exciting times ahead for the, you know, for timber in terms of what can be done. And this is the slide we like to finish on. This is the number of tree seeds that grew the trees that built our first tall building, Murray Grove. Thank you.
Okay, quite exciting and inspiring. I stop sharing and give the screen to Ian and Sam.
Well, good morning, everybody, and how inspiring is that? It's great to hear Andrew and the tremendous work that they're doing. And it's really a great context setting for why Timberlink is investing in this category. There's no doubt that timber engineered product building solutions are in the next stage of market growth. As you look around the world, it's clear to see that just the investment that's occurring in manufacturing, in the capabilities in the supply chain and at the customer end is really on an escalation journey, and probably only has been slightly dented by the impacts of COVID. But we're seeing really that the benefits of that system are now completely much better understood, and the momentum is really undeniable. The market acceptability, of course, has significantly changed. It's a more defined, understood set of benefits that Andrew took us through. The innovation in building and manufacturing capabilities is exponentially changing. The smart and integrated technologies around the value chain are significantly changing. There's less risk then for people to invest and adopt a position within the mass timber area. So as we're thinking about why mass timber, we're looking at these things to say, is this the right place to put a significant investment in? Are we picking the right timing? And we understand that buildings and building design and design in construction is moving from old processes to new processes. And then the question is, how is that going to manifest itself into the supply chain that's feeding into that? And who is going to invest in that and unlock those benefits? So we're moving from this old process to new process. And I'm sure you've seen these in many ways where you start with a concept of a person working through it, and eventually ends up with a lot of people actually delivering it at the building. And what we're seeing is that completely changing through automation, through manufacturing in different ways, to less people then on site and less impactful on the construction end of the equation. So we believe that people in the value chain that are in construction now will be more aware about understanding, well, what's our position in there and what does timber mean for us as a business? And some will adopt perhaps new positions, some will continue to pursue those and become a larger part of the business, Or some will look at it and say, well, look, perhaps there's a hybrid position in here, and we see globally there's a lot of work where steel and concrete are becoming incorporated, or maybe timber is being incorporated into steel and concrete structures, and each perhaps has some benefits attached to that. Everyone will have their own risk and benefit outcome profile, but what we believe is, as we're seeing this market change and develop, that the risk profile for people involved in this category is now significantly reduced. And when we look at our position in that, as an integrated manufacturer from forest to customer, we believe that there's a position for us to add the greatest amount of value that we can to the natural resource that we're responsible for. So understanding that the natural resources are not infinite and that we need to deliver greater value from those resources, how do we go about doing that? What are the unique benefits for the building materials? How do we expand into products and markets that benefit from this? So we believe an investment in mass timber then meets our objectives as a business while creating a more diverse, profitable and sustainable business. Leveraging from high volume, modern and efficient Australian-based timber manufacturing plants. So coming from a base where we've invested significant capital, time and effort to make sure that the manufacturing assets that sit behind the investment that we're making in turning that into panelised systems and beams and so on, that they integrate into being able to provide a sustainable solution for the Australian market. So we're really excited to be able to make that investment, supporting by creating a world-class CLT, GLT manufacturing plant, an integrated plant at our Tarpina sawmill, which Simon will talk a little bit about, and providing a highly skilled technical service and support team in Australia that will stand behind that. I'd just like to show you a video which I think highlights how we're seeing this as a category for Australia and what it means for us as a business, how we think the end market. Thanks for the opportunity to have a chat.
It starts with a seed from nature, with soil, water and sunshine added. It's what a better tomorrow will be built on, built out of, built with. It's what the craftsman, the draftsman, the architect, the engineer, all those who shape tomorrow should lean on. If it can be renewable and store carbon, it should, and it can. And if it can be done quicker, quieter, smarter and safer, it should, and it can. You see, if we treat our buildings as living, breathing things, then the living, breathing things that inhabit them will have a future to look forward to. Everything we do today matters, for tomorrow will be where we all reside. However you use Next Timber, you won't just be building a building, you'll be creating a better future. Next Timber by Timberlink. It's what better tomorrows are built on.
Thanks, Ian. When we commenced our journey into looking at the opportunity for us to enter the mass timber market, it was really important for us as a company to really understand these key market drivers, most of which have actually come through, of course, in Andrew's presentation earlier. But these are real. Just the discussion around waste reduction on site, the talk about the construction industry needing to build differently and build better, the push towards urbanisation, living in a city space is a premium, so building up, not out. Lessening this activity on site, the safety performance on site, trying to improve that, really, really important driver. We understand the lightweight nature of timber, and it's been well explained the benefits of that. The speed of construction, really important for the developer, really important for the builder, and as Andrew really touched on, really, really important for the neighbours around that building site. But it's really emerging as this biophilic push and values about this warmth of timber, good health and well-being is really coming to the forefront now. And it's really locked around this key driver, the key cog of sustainability and environment. And we believe that this is being embedded into business thinking, to living. So it's important for us early to understand these key drivers, but also understand that these are not just fads, these are sustainable long-term drivers of our industry, and we believe that they are. Timberlink has a sustainable supply chain model. The Timberlink is a portfolio company of New Forest. New Forest is the second largest forestry management company globally. We have over 7 billion funds under management based in Sydney. The Timberlink business, the sawmilling business, has invested over 200 million to date in upgrading our sawmills, and that's not including the new investment plan that we're building now for the CLT and GLT plant, which is a further 63 million. And the important point here is that we just didn't decide some months ago that we might build a CLT and GLT plant. This has been long embedded in our strategic thinking, in our planning, and what's next for Timberlake. And we believe that the sustainable model is one that carries us into the future. And the point that we've invested recently this money to upgrade our sawmilling capacity, as recent as the latest upgrade of about $90 million to the Tarpina saw line upgrade, will see us not only continue to service our existing customers and our framing business that's key and core to us, it will also allow us to have a sustainable fibre model as we launch into the next timber business. So we believe that the next timber business and brand takes us into the new value-added next step in the supply chain. To be able to do that, the systems integration piece is critical. In some respects, this is a new business for Timberlink. It's deeply embedded in our business. But Next Timber is a new business. We are doing things differently. And to be able to do that, we have to have a fully integrated system to carry us right through. From early modelling and assisting with specifiers, architects and engineers to specify our products into their developments, and being able to carry that information through to our new manufacturing plant, and then circle back and ensure that we're delivering in a logistics model that's sequenced bespoke project deliveries to suit the customer installation on site. So this is a totally different model for our business. So we've formed and we're formulating and implementing designated CAD software program, and this is really critical for us to be able to implement our new business model. So our new products, our CLT and GLT, will be carried into the specification market under the new brand, Next Timber. So we've created this brand to allow us to move into this new market, this new specification market. We understand that it's a much different selling process than our initial our core business. Long lead times on specification times, 6, 12, 18 months, 2 years working on projects. And we believe that this brand will carry us in. And this leverages off our existing Timberlink capabilities. Our product testing and trials, it's a really important part of what we're doing. And this won't just start when we turn our plant on. In fact, we commenced our testing regime in 2019 on our raw material, our product testing, our version 1 of our first stage of our product testing has been carried out this year, which has enabled us to produce a set of technical specifications, our first version of those. Our testing program will be ongoing. This is going to be embedded into our business moving forward as we move further closer to 2023, where we'll have a development of a suite, a library of products, of tools that specifiers, architects, engineers can go to quickly and enable them to specify our products. Our timeline to commercial production. We've started our plant design, 2021, our plant design, and in fact the selection of our equipment suppliers is completed. All our orders are placed. We're expecting some of our initial equipment to arrive in the next year, and we'll then work through a commissioning stage of the building of our new plant for then production and supply in the later part of 2023. just draw your attention to the bottom left-hand photo, which is our Tarpina site as of November last month. And you can see that the site works are well underway and getting ready to build our new facility, which is represented in the middle diagram. That's a 14,000 square metre facility right in our Tarpina sawmill, which has been recently upgraded, as mentioned earlier. And we're really excited about seeing that come out of the ground next year. And of course, in the early half of 2023, we'll have equipment installed. We'll be commissioning our plant and commissioning our new products ready for market entry in later 2023. The important point here is that our market engagement and our technical support is available now, and it starts now in line with the long specification times for projects. So we're ready to speak to the market now. Just like to draw your attention to our new website. It's up and ready for you to explore. We've got a lot of information on there. Our first technical guide publication and our corporate brochure that will give you a lot more information around what we're doing and the performance criteria of our product. So we would encourage the market to jump on the website and have a good look. So we're at Timberlink, the formation of Next Timber. We're really confident in this growth and the uptake of mass timber in the Australian market. We're really excited to be servicing that market. And we're committed to a long journey by adding our additional supply availability to the market in 2023. And we really look forward to working with markets as we prepare for that entry in 2023. We have some time, but we have no time to waste. So we're really keen to engage. I've got some contact details there on the bottom of the page. Please feel free to drop an email or call. We have a great internal technical team that will be really pleased to speak to anybody as we start to move forward. I'd just like to thank Ian and thank Paolo and the Wood Solutions team for some great webinars this year. We really appreciate the opportunity to speak and present today. And I'll hand back to you, Paolo. Thank you.
Thank you, Simon. We have a few questions, but good ones. So if you don't mind, have a look at the Q&A and we go through quickly. It's already 12, but for those of you who want to stay with us another few minutes, there is a question from Troy about the BCA, NCC. So for class 2 buildings, currently there are two approaches and for all the classes. One approach is the deemed to satisfy, which was approved first in 2016, then modified and improved in 2019. So it's already there. It allows timber structures to be used as a deemed to satisfy solution, so cladding the structural timber up to 25-meter effective height, which according to the floor-to-floor height that you are using in your design means 8 or 9 story. We have a lot of documentation, a lot of knowledge and support tools for this. So please contact us at the Mid-Rise Advisory team if you have a project or if you want more information about that. Then Mike Campbell is asking about the termite problem. Are there any toxic components used in mass timber construction that may gas off in the long term? So termite has a completely different approach according to the area you're building in. In the southeast, Melbourne, Sydney, Adelaide, etc., and Perth as well. Currently, there are only ground termites, which cannot live into the light, so they have to live only in the ground or create some tunnels to access timber above the ground. So the simple and effective method to deal with ground termite is using steel meshes onto the slab, into the penetration into the slab, and that brings services up and down into the building. That's what the code prescribes. This is what good design prescribes. So there's nothing else you have to do for termites in this area. So there's no preservatives that you need to use. In the semi-tropical and tropical areas like Brisbane and north of Brisbane and Northern Territory, etc., there are flying termites which can come through the window. So these type of termites require timber to be pressure treated for application in these areas. It's water-based treatments. They are approved by every authority, so they are not gassing out in the long term. As far as I know, they are fully approved and therefore considered safe for human use of the buildings. Then, and please, Simon, Ian, step in at any point if you like.
You're doing a great job, Paolo.
What average depth is the floor plate in Andrew CLT buildings? Looks around 250. Yeah, that can be. And I'm not sure what it is in each of his projects, but we can ask him if you have a couple of examples that you are particularly interested in. We can get the construction details from him, but 250, 300 makes sense in terms of the structural part, the finish on top, so the acoustic mat and the floor finish on top, and drop ceiling on the ceiling side. If there's any installations like electrical and plumbing for the sprinkler system, for instance, that are kept not visible. Otherwise, they may be run like in commercial spaces. They are made visible, and therefore they don't affect the floor-to-floor height. Tim Williams, Timberlink seeking a no VOC glue for their GLT and CLT production. That's up to you, Simon.
Thanks, Paolo. Tim, good question. We're right in the final parts of our process of determining our glue adhesive options. So we'll be able to give some information to the market exactly on where we're heading with that in the very near future. We're just a bit early for that.
Yep. And anyway, all the glues which are approved for CLT and GLT construction, they go through a certification for the structural performances, but that includes also very low formaldehyde emission, if that answers your question, Tim. Whatever is the nature of this glue, there are glues which have zero emission, there are glues which have really close to zero emissions, and they are all, approved. Adrian, exposed services, Mac Electrical, yes, they can be incorporated into the panels, but more frequently they are not. Only in a few parts they can be grooved into the panels, or there may be holes to dip down the surfaces in a floor plate, but most typically they are not incorporated into the panels, but both are possible. So if there's no more questions, I thank all of you for attending this webinar.